So I guess in the last session, well, the goals were sort of twofold. One, we wanted to show you how you don't actually need much coding expertise to get your data into BIDS. It's sort of just, all it is just a naming scheme, essentially, with a bit of metadata attached to it. So one thing we want to show is that it's easy to get your data into BIDS, but then, it is a bit painful, right? You went through it. It was, you did this one subject. It took some time, right? You might be asked, so do you have to do this every time you update your data set, you get a new scan? Like, how do you actually, is it worth, doing that task for what you actually gain? So we've been trying to develop tools to sort of make that process easier. And I don't, who was here for the last session I had done on BIDS? There was a methods lunch, I believe it was a couple months ago. Okay, so there, what I was showing was, it was a set of tools that you could use using Linux with containerized environment Singularity to convert your data to BIDS. Now the problem with that is it's still not completely accessible. So you still need to know how to use Linux. You still need to do stuff on the command line. You have to edit a heuristic file. And so I don't know how many, so out of those people that attended that tutorial, did anyone actually try to use the software? Okay, sort of, yeah. Okay, so what we've more recently embarked on since then is actually to provide a fully automated service. So that works specifically with the CFMM scanners, so that anyone can just sign up for this service. Once you sign up for the service, there's a little bit of initial configuration. We work with you to get that set up. This weekend is a good time to do that, actually. So our goal is to get as many studies set up as possible. But once you do that, basically anytime you get a new scan, you acquire a scan on the 3T or the 7T scanner, you'll get an email notification. There's going to be, I'm probably getting ahead of myself, but there's going to be a link to your data. You can easily download your data. You don't need any special accounts or anything like that. And then you have BIDS. So that's what we want to get people using. I think that's the sort of the easiest way to get into this sort of BIDS environment. So, but what I want to talk about today, so I'm going to talk about what is, so I just basically described at a high level what is AutoBIDS. Before I get into this fully automated service that we're providing for people, I want to talk a bit about how our lab uses AutoBIDS, just more for sort of clarification, because there are some people in here that we collaborate with that have been using this system. So just to be clear, what our use of AutoBIDS is versus what we're providing for any CFMM user. And as I go through, please interrupt me at any moment if anything's unclear, if I spit out some jargon. Cool. Okay, so so basically the whole way this works is we get someone in the scanner, DICOMs go over to the DICOM server. We get those DICOMs automatically once they're pulled over to the DICOM server. We ship them over to a high-performance computing cluster where we have lots of CPUs and lots of terabytes of storage. We have this software sitting there, AutoBIDS. It automatically converts our data to BIDS, knowing what data set it is. And then from there, we can use, our data now lives on this compute server because that's where it was converted, and then we can do all sorts of things with it. So we can run our processing pipelines, we can do our analysis, we can log in and work with the data there. And so we end up with sort of an easy way to go from DICOMs to fully preprocessed data. So this is sort of how we're using AutoBIDS. And the sort of components here, so in my last tutorial, I basically went over these two pieces. So CFMM to tar and tar to bits, right? So we've basically broken it down into one tool which pulls data directly from the CFMM DICOM server, and it just basically puts every single session into a separate tar file. So the way you would use this tool if you wanted to, this is what I described last time, is you just specify what date you want to retrieve or what range of dates, and it just goes and just downloads those, and you log in with your account. And then the actual conversion is done with another tool where you feed in these tar files and you tell it, you have to provide this set of rules, which I'll go through later, which we have mostly pre-configured already, and some way to also define what the subject ID is. So what AutoBids is, it sort of builds a layer on top of that to just basically configure everything else about a study. So this is sort of on a sort of session by session level, if you want to grab the tar file for a session and then convert it to bids, or a number of them. And AutoBids just provides another layer of sort of configuration and automation to do this process for any number of projects. And this is right now the way we have it deployed. It's all on a Compute Canada cluster gram, where we have many, many compute nodes that are at our command. Okay, so just before I go further, how many people have actually used a high-performance computing system? Okay, so maybe like half. The main difference, actually, what else? I'm going to start with the next slide because I think this should have been first. So with the HPC cluster, so unlike your own computer where you can just sort of log in and just run your jobs, it's a shared resource, right? So on your personal computer, you just sort of you sit down, you log in, you enter your password, right? So now you have complete control of that computer. You can do whatever you want with it. You can install software. You have possibly admin access. You can run your code, and then you wait for it to run. You get your result. And you can visualize it, do whatever you want with it, right? So the difference is when you're on a shared HPC system. For one, you have to now remotely log into that computer, right? And that's all through command line. These computers don't have any sort of graphical user interface at all, so you're doing this through SSH, right? And now, because it's a shared resource, you have to, anytime you run something, you actually have to make a specific job request, right? So you want to say, what program to run, what's the command to run, how much memory is it going to use, how much time do you expect, at which it'll just terminate if you go past that time, how many CPUs to use. And so there's a whole process of sort of just doing something on a high performance computing system. And once you actually do that, so you submit a job request, you wait. Because that job doesn't get run on wherever you've logged into, it gets run on some other node which is sitting in this huge server room, right? And then you get your result. Now you have your data. It's on this system, but say you wanted to run, say you want to view it with FSL. So then you have to actually get your data, right? So you have to download it through SSH, or sometimes you can use SSHFS to mount it, but that's another thing you have to do. So ultimately, so hopefully the message I'm getting across is that there's there's a learning curve to doing things on HPC. I definitely recommend people to start doing this. I think everyone in my lab is getting some experience with this now, but for anyone that's not used to, first of all, Linux or doing this sort of work, it can be quite intimidating, and there's a learning curve. It'll take time to get used to this. So so just more motivation, I guess, for why you just want something that just does this for you, I guess. So a little bit about AutoBids just under the hood. So it's open source. There's a GitHub for it. It's in Python and Bash. This has been mostly co-developed by Ying Li, back in the back corner there. Raise your hand, yeah, and myself, and tested by a lot of people in our lab and in Robarts. We make use of Singularity containers, as you heard from Olivia. So these are to package up our dependencies. And for the actual conversion, we use a lot of, so we're not reinventing the wheel here. We're using a lot of existing tools, but we just make it a bit easier to use. So, DICOM to Nifty, that's already a very easy to use tool, but it works quite well. QtConv is one tool out there for bids conversion, but it's quite powerful, but it's a bit tricky to use. It took me actually a long time just to get it working. And so it uses this set of heuristics, right, or rules, which are sort of scripts in themselves. So you need to have those set up before you start using the software. And the software itself, it's unintuitive in many ways. So has anyone ever actually used this directly, QtConv? No, Olivia. Okay, so actually, the way that AutoBids initially started was I didn't want people to use this directly because it was just really painful. So so after I went through the pain, I made a wrapper to it, and then that just sort of evolved. But in any case, it's actually a very powerful piece of software, and it uses its DICOM to Nifty itself. So we make use of QtConv, which makes use of DCM to NIAX, which does the actual, this is the workhorse for Nifty conversion and JSON generation. This adds some more JSON and bids standards to it, and then we add an additional layer of Python scripts for further cleaning up that bids output, and also making it specialized for some of the sequences that we work with, like multi-echo. And for pipeline execution, so we use another library, in-house library of wrappers for running Singularity and bids apps on Compute Canada. So if you are interested in using Compute Canada, then this would be of interest to you. Now I want to show you just really quick, just an overview of what kinds of sequences that we do account for in our heuristic files. So I tried to make as an exhaustive list as possible. I might be missing some here. So MP Rage, MP2 Rage, and when we extract MP2 Rage, for instance, we extract all the different drive data that you get from it as well, like the flattened maps, the T1 maps, all the different echoes from multi-echo MP2 Rage, multi-echo GRE. If you, by default, when you acquire multiple runs, say you acquired 2 different MP2 Rages, then it'll label them run 1, run 2. So all the different sort of structural images you might acquire on a CFMM scanner. Diffusion, so it'll deal with any kind of phase encode direction that you acquired, putting the data into the JSON file. It deals with GRE field maps. If you're doing anything like blipped encodings for fMRI, then you might need some customization there. It also deals with SATU Rage and some Angio as well. So for bold data, so it deals with all the different major types of data types you get from bold. But by default, so this is in our standard heuristic, by default, it'll assume all the tasks are resting state. So that's because, I mean, there's no way for us to know what kind of task you actually have unless you have some standardized naming in your script, right? So So the task is something that needs to be customized for each protocol. So that's part of what we have to do when we're setting up a new study. And so I'm going to give you an example of just what that's like. So in this study, someone had a task, fMRI, and what they did when they were acquiring the scan, in the series description, they just put, so this was a localizer. It was a type of a localizer. So they just put LOC somewhere in the series description. Okay? So then what we have to do in our heuristic file, we basically have to add a couple lines to it. So first thing we do, we create this key, okay? We're calling it loc. And what the key is basically, this is the path of where the output file is going to go in our BIDS data set. So sub, func, sub, and here, so here, this is a loc task, right? The run is going to be indexed by something, okay? So this is basically QtConv's language in a way, right? So this is one thing we would have to do, okay? And next thing we have to do is we actually have to come up with a rule. So when do we actually assign a series to this key? So all I'm doing is I'm saying, so if loc is in the series description and the fourth dimension is greater than 1, then we're going to add it to this key. So what this basically does, so if we add these 3 lines to our standard heuristic file, we basically extend our standard heuristic file and make this a new heuristic file for whoever study this is. Then now this heuristic can deal with this type of a task. So this is just to give you an idea of what level of customization needs to be done for different tasks. So it's actually it's really not that arduous, and this is something that we're going to help you create and test out when you when you set up a new study for this service. Any questions so far on that? Okay. The other thing that we can do with this, with AutoBIDS, is actually we can set up a pipeline to run post-conversion. So this pipeline would be triggered, and the way we have our wrapper set up is this could also be just a sequence of pipelines or a number of pipelines that are run in parallel. So for instance, we can use this to run MRI QC every time we get a new scan, or fMRI prep, or any of our in-house BIDS apps. Or in general, it could actually be any kind of script or pipeline that acts on a BIDS data set. So it doesn't even have to be a traditional BIDS data set. And so this is also something customizable in our study configuration. So just to give you a teaser of what we're working on in terms of automated pre-processing, what we want to do in the near future is to have a completely exhaustive minimal pre-processing pipeline for anything 7T MRI. So this would do gradient unwarping on all your data, skull stripping using a library of accurate 7T skull stripped templates that came from the same scanner. T1 pre-processing for any other inhomogeneities. Same thing for any other T2 beta scan you get. QSM pre-processing, that some of this is done already. DWI pre-processing, that's our prep DWI pipeline. So ultimately, what we want to end up with is instead of a user downloading DICOMs and doing all this pre-processing themselves, what they would get is not only get a BIDS data set, but they would get a fully pre-processed 7T data set, which sort of trying to overcome all the challenges that make 7T hard. So at the end of this, you would have a nice set of clean images, which you could then feed into whatever other analysis that you want to do. So these then become almost as ubiquitous as 3T MRI. So then you can pass this through fMRI prep or what have you, and you would get robust results. So this is something that we're working on. We're mostly there, so watch out for that soon. So just to summarize, so the way we're using it, it's really just one piece of a larger set of pipeline and data infrastructure that we have deployed. And you know, we're working on this with you know, access to Compute Canada, where we have a resource allocation. And so basically, all of these things require a number to actually use Autobits like we use it. It requires a number of things. So it requires Compute Canada accounts, requires this resource allocation. So for instance, like every year a PI can request an amount of resources to use on Compute Canada. So we have 50 core years and 200 terabytes of data that we can make use of. If you don't make that request, you just get a default allocation. But any PI can actually get access to Compute Canada. But it's just another step, right? And it'll basically requires experience using HPC systems. So I'm guessing some of you can attest to just the learning curve that you get with that. And also being able to use all these tools. So, okay, so finally, so what about everyone else? So this is what I was sort of leading up to. So if you don't meet these requirements, how do you use Autobits? Okay, so this is the actual, so the Autobits pilot program phase. I'm calling it phase 1 because we're still limiting access somewhat. So you'll see what the limitations are in a later slide. But basically, so now the way the workflow is, once you have a study set up, you would scan a participant, DICOMs would automatically go to Autobits. So this is still under our control. You would get your email notification. So in this email notification, it'll have your study name, the import complete, it'll have the patient that was scanned. It'll have BIDS validator output. So the text output from the BIDS validator would appear here. Okay, and then you would get this link. So this is a link for a file download through Globus. So Globus is actually a really nice piece of software. It's what all the compute clusters around the world use to transfer data. So Compute Canada, our node, actually has this enabled. So once you click on that link, basically you'd be given access to this web app where you can just log in through, I think you can link your Google account to it, so you don't actually have to have a Compute Canada account to download this. But what it would bring up is basically something similar to an SFTP site, or something where you basically have your remote data on one side, and this could be any machine that you control. So that's what the endpoints are called. So you could have this software running on your laptop or your server or your workstation, and then you would see that folder here, right? And then you would just select all and then hit that button, and then your data would just be transferred. So you never have to actually log into to this machine in order to access the data. So a bit about Globus. So if anyone wants more information, they can just go to globus.org, I think. But it's basically, it's kind of like a job submission server in itself. So you're interacting with it through this GUI on the web. You tell it what files you want to transfer, and then it moves the data for you. So it can move data from some secure endpoint to another secure endpoint, which is actually not what you guys are doing. You guys would be moving data from a secure endpoint to your own endpoint. And you can even actually do this on your phone. So like if I click one of my links in my email, I could actually transfer data to whatever computer that I control. Okay, so what do you actually need to do to use the service? So We set up just a simple study request form. I'll go on there in a sec. Actually, I'll go there now. Just to show you, it's not really a whole lot of information. So your email address, your name. Okay, this general information is just really more for demographics of users. So I want to know who's using, who's benefiting from it. It's more just for understanding how it's impacting people, how many scans you expect, okay, longitudinal or multi-session, and just to sort of just to get an idea of what your experience is with computing. But the actual information you need to pass on to us is mostly from the information that you have on the DICOM server already. So what's the PI identifier, what's the project name, and that project name would be used as your BIDS data set unless you want a different name here. So one of the reasons you might want a different name is if you have multiple projects under the same DICOM server project. So there's a way to deal with that by having a different identifier for each one. And then basically what we want to know is what's a date we can use, what's a session we can use to test out the conversion. And if there's retrospective data that you've already acquired that we want to convert, when did those start and when did they end? And so what you are consenting to, so again, so this is just completely optional. No one using the CFMM scanners has to use this. And I mean, we don't make any guarantees regarding quality of service, but you know, we will try our best to give you validated BIDS data. And that's pretty much all we're guaranteeing to you right now, just pretty much BIDS data accessed in this way. The typical turnaround time, I think, has been 20, 30 minutes after the scan, just for everything to sort of run through. One thing you have to do as well is did I say it here? Well, yeah, so you also just agree to acknowledge use of this when we eventually have a paper, you would cite it. But this is not sort of agreeing to collaboration in any way. So this is still, you know, we're not asking for authorship. One thing you do have to do, though, is you have to share your data with us by adding a user to the DICOM server. So when you're managing your settings on the DICOM server of which users to share with, there's a BIDS dump user, and you just have to add that person or that virtual person to your sharing list, and then that essentially gives the system access. Yeah, okay, what else? Any questions so far? Yeah.
Curious. Are there plans to use this on the 9.4T?
Yes, definitely. Actually, we have some test images just as of a couple days ago. We're going to try to get everything ready so that once it's up and running, we're sort of good to go. Yeah, but
Part of
yeah.
its commissioning is making sure that it's DICOM server compatible. So even that is currently ongoing. My understanding. So.
Mm-hmm. But yeah, and also, I mean, we'd appreciate, you know, getting test images and things like that to get that going as well for the 9.4. Yeah, so first thing you would do is fill out this new study request form. Second thing, grant read access to this user, to your project. And then basically it's a sort of iterative process to test and optimize that configuration. So, right now it's me. In a few weeks it would be the new BrainScan neuroimaging analyst, which would take over a lot of this sort of legwork. But basically what it involves is just setting up your study config file and then running a test. And then you would get an email, you would click the link, you would check if it's bids, check the bids validator output, see if everything is there that you need it to be. And if you're good to go, then we can run one command which does all your retrospective data from 2 different dates, or from a range of dates. And then from that point onwards, you'll just be receiving email notifications whenever data is ready. Oh yeah, so this is basically what the admin has to do. So it creates a study config file. The way we share data, so basically on our system, on our Compute Canada system, your data will be kept in a folder that's unreadable by anyone except for me, basically, or the administrator of this software. So it's not accessible to our entire group. The way we share the data through Globus, that's how we set up the access. So anyone that wants access to the data and to receive notifications, we can just add their email, and then they would have access and they would get notifications. Do the test conversion. And this is mostly for task data, really, customizing the heuristic. And yeah, as I mentioned, so the new BrainScan neuroimaging analyst will be spearheading this whole initiative once we get it up and going. So just a couple tips on if in case anyone's sort of designing or has yet to start a study, some things to think about. So when you're scanning your subjects, so the patient name field is basically what the operator is typing in to identify your study, right? Everyone's familiar with this field? It's basically on the DICOM server what identifies that particular session. So it's always good to make use of a BIDS compliant label there. So no special characters, letters and numbers are good, and make sure it's good to have it zero padded because it's just nice so that things appear sorted. And you should always try to have a consistent delimiter. So one easy way to make sure that's the case is always have it at the end of your string, for instance. So something, 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 underscore, and then your subject ID, right? So there's ways that we customize how we search for this in your field, but it always helps to be consistent. Now, if you have longitudinal or multi-session data, you should also make sure that you include the session identifier. So that's like session 1, session 2, or session pre, session post. Try to include that identifier for all the scans, even the baseline ones. Because what you see sometimes is you'll acquire data where you'll call it subject 0051, right? And then they come for their follow-up, and then you call it subject 0051 follow-up. What makes that tricky is now you can't just use a simple expression to find what the session is, right? Because the session doesn't exist in this tag, right, or in this string. So if you know you're going to do longitudinal data, try to have that session label somewhere in the name, right? So use that baseline tag, or use that pre, or 1, or 0, or something that identifies the baseline scan as well. There's ways of getting around this, but it'll just make life a lot easier for us. And same thing, so when you're doing a task, put the task in your series description, task name. I think most people do that, just for their own sanity. Okay, so some limitations that we have. So we don't yet deal with physiological data, like respiratory or heart rate. That's something actually we can probably do this weekend if we have time. Spectroscopy, I'm not promising anything. It's all up to Dixon.
That's 100 weekends from now.
Yeah.
There's a project for it.
Exactly. One thing, so not all the sequences that we generate in a bids format are actually included in the bids validator at this point. So we're using some 17 sequences that are not in the current bids draft. So bids will complain about those, but you'll get them, and it's just up to us as a whole to sort of add those to the bids standard. One thing, so it doesn't deface images, but we can easily add a defacing pipeline, post-processing pipeline as well. Right now, and this will also probably be fixed by this weekend too. It doesn't deal with longitudinal data, but that's something that I already have a branch that does that, so it's just a matter of testing it out. And okay, so the major limitation as for right now for the phase 1 of this pilot is we're not able to run the really computationally intensive pipelines for everyone's data. So this includes fMRI prep and prep DWI, because these can take a day or two running 8 cores at once to actually complete. So if we did that for everyone, we wouldn't be able to get to use the computers ourselves. But this will change in the near future, probably in a year's time, when we actually can request a larger amount of resources on this cluster. So, but you can still run the sort of core post-processing. So we're able to run MRI-QC, and we're able to run gradient correction, because I think these are really important to run on your data. Well, gradient correction for 7T data and MRI-QC for any data, just to know what you're dealing with. Yeah, so see you at the hackathon, I guess. And if for any more details, you can see here. But yeah, any questions on that? Hopefully everyone's... Is anyone planning to use this service? I know, Juan, you signed up just now, so...
Yeah, but I realized we may not be able to get access to the data by Saturday, because now it's
Oh, okay, you're not an administrator on the...
Yeah.
Oh, okay.
So in that case...
In that case, we can still test it out if you have the files.
Yeah, I have the
Yeah,
file on my
sounds good. Yeah. Cool. All right. What is next? I think we have a break. Yeah?